Let's take a look at a couple examples so we can internalize this idea of elementary matrices. So let A be a 3 by n matrix, okay? Doesn't matter which matrix, just, 3 rows, however many columns. Now, suppose that we apply a particular elementary row operation. In particular, we are taking 9 times row 2, we're storing the result in row 2, and we're applying it to matrix A, and the resulting matrix is matrix B. We want to find the elementary matrix E equivalent to this row operation, so that when we left multiply matrix A by the elementary matrix E, it's the same, it gives us the same result. The same matrix where the elementary row operation has been applied. Okay? Now, from what we've just seen, from the corollary we just proved, in order to find an elementary matrix that corresponds to a specific elementary row operation, all we need to do is we need to apply that elementary row operation to the identity matrix. In this case, since A is a 3 by n matrix, we want a 3 by 3 identity matrix to make sure that the matrix multiplication is well defined. Okay? So our 3 by 3 identity matrix is 1, 0, 0, 0, 1, 0, 0, 0, 1. If I apply the elementary row operation to the identity matrix, 9R2 is my new R2, then all I'm going to do is I'm going to multiply row 2 by negative 9. And I get, so row 1 stays the same. Row 2 becomes 0, negative 9, 0. Row 3 becomes 0, 0, 1. Okay, this is my elementary matrix. It is what I get by applying the one elementary row operation that I'm interested in here to the identity matrix. When I apply one elementary row operation to the identity matrix, I get an elementary matrix. Now, what this elementary matrix does now is if I multiply any matrix A with 3 rows and any number of columns, okay, if I take E times A, that is the same as applying the elementary row operation, negative 9R2 to R2, to matrix A. It does the same thing. Let's take a look at one more. Again, let A be a 3 by n matrix. Suppose the results of applying the elementary row operation, R3 minus 5R2 to R3 to matrix A, is matrix B. We want to find elementary matrix A so that multiplying the elementary matrix E times A gives us the same result as just applying the elementary row operation. Okay. As before, we want to take a 3 by 3 identity matrix and apply the elementary row operation to the identity matrix. That will give us the elementary matrix. So R3 minus 5R2 into R3. Okay, so the only row changing here is the third row. So row 1 and 2 will stay the same. For row 3, I'm going to take row 3 and then I'm going to subtract 5 times row 2. So 0 minus 5 times 0 is 0. 0 minus 5 times 1 is negative 5. And then 1 minus 5 times 0 is 1. And so this is our elementary matrix. And so we could apply this elementary row operation to any matrix with 3 rows by just left multiplying that matrix by our elementary matrix E.